So hello all, welcome to another session with me, Varun at TechTablet. And in this session, let us understand the importance of statistics. Why do we need them? And there are a lot of people out there who are actually aiming or who are aspiring to become data scientists, and there's a lot of confusion out there in the market or out there amongst the people who are preparing for this branch. That is, if statistics is really important, or how important is it, or what is it? So in this session, let us understand what it is. So you all know me. I am Varun, and in order to follow me, you could use my Instagram account, which is Hyderabad_Chora, or you could follow me on my Facebook account, which is Varuna_Gemini at yahoo.com. So without wasting time, let us understand what is the agenda of this session. So as discussed, the agenda of this session would be to understand what is statistics, important terminologies related to statistics. Is statistics really needed for us, and how deep do we need statistics in order to start machine learning, or in order to go ahead and start working as a data scientist, or probably as a data analyst. And I started working as an SAP ABAP developer, moved on into SAP UI5, then started my YouTube channel wherein I started with SAP stuff, and then moved on into data science. And currently I work as a corporate trainer, or as a trainer full time, and I am into the data science field. And I also do rap videos, and that is the exact account which you've seen on my Instagram, which is Hyderabad_Chora. And that is something I do for passion. And I work on R, Python, and TensorFlow. So let's begin and understand what statistics is. Now, talking about statistics, it is basically concerned to be a science. All right. So as you can see here, guys, statistics is a science. And statistics, as a lot of people consider to be, it is not a subject that you kind of study, or you memorize. It is a science that you understand. And in this science, we mostly work on collecting, analyzing, interpreting, and presenting the empirical data. Now here, when you talk about data, this data could be in any form. It could be clean, or it could be unclean. Now when I say clean or unclean, there might be a lot of data cleansing required, like removing unnecessary columns, adding some columns, or probably checking out the mean, or filling the NA values, introducing NA values, and then probably again removing them. So there are a lot of procedures which we follow to ensure that your data is cleansed, right? So here, that's what we're talking about. When we talk about statistics, statistics would give us an insight about your data. It would help you understand your data better. So, which is the reason why it can be explained as a category of mathematics, which is used for summarizing, interpreting, and analyzing. That's exactly what we've seen here as well, and that's the same thing here. Now, when we talk about summarizing, or when we talk about interpreting, when you look at a graph, there is a whole lot of information that we understand. It's not just what is written on the X and Y axis that we could infer from. There's also a lot of other insights that we could gain when we look at a graph. Now, all this is a part of statistics only. And one of the major conceptions that we have in the market today, or that we have amongst a lot of aspirants today, is that we should have very sound basics in mathematical concepts. Well, I wouldn't say so, or I would, probably not hesitate saying that it's completely wrong. Yes, I would say that you should have knowledge on mathematics. That's not an argument. But then, if someone tells you that mathematics, you need to be a master's at it, or probably you need to be very good at it, then you might want to reject that kind of an advice. Now, another mistake that students make is assuming that science or computer science is a background that is required for you in order to get into data science, which is also wrong. I have seen people from different backgrounds, like there's a good number of people who get shocked, but I've seen people completely from irrelevant, non-technical backgrounds. Like I have people from pharma, I have people who are from history or commerce background. I have seen people from BTech, which is something that we all know. I have seen people from a lot of backgrounds. So background shouldn't really make a difference if data science is what you're planning to choose. All right. So now, without wasting time, let us move further. Now that we've understood what statistics is, and now that we know, even if you are from a technical background, or even if you're not, it shouldn't make a difference. Now, keeping this in mind, let us go further. Now that we've understood, there are two types of statistics, or rather, there are two ideologies in the field of statistics. The first one is uncertainty, and the second one is variation. Now there are many day-to-day situations wherein we encounter these words, or wherein the outcome is uncertain, or wherein we don't know what would happen, or wherein the variation, like for example, I have expected that I would gain 10 rupees, or I have expected that I would be traveling 10 kilometers, but it's turning out to be that it is 12 or 9.8. Now, in this case, there is both uncertainty in what I have calculated and what I've thought, and a variation in what has happened and what I've calculated. So, guys, there are many situations, but when we talk about data science, these uncertainty and variation which we're talking about, they need to have a value. You cannot say that there is uncertainty. And when I ask you what is the uncertainty, or how much is the variation, or how varying are they from each other, you should have an answer. And that answer should be quantified. It could be in percentage, or it could be in numbers. And if you do not have an answer in that way, then there's a problem. Now, we are talking about statistics. In order to sort that out, we have two variants. The first one is descriptive, and the second one is inferential. In descriptive, we use it mostly for summarizing observations, wherein the values are precise. You have precise values, but when you're talking about inferential statistics, they are mostly for interpreting the meaning of descriptive. So without descriptive, having inferential makes no sense. So it might sound a bit funny, but descriptive and inferential are dependent on each other. They both need each other, and when they are used with regards to each other, they make complete sense, or what you want to understand is complete, is what I would at least like to say. Now, going further into statistics, we would just understand about each of them, and then again let's come back to the topic. Now, talking about what are the different types of descriptive statistics, and even before that, let's understand what descriptive statistics is all about in the first place. Here, as you can see, descriptive statistics, the goal is to describe. The word says it all. Describe, descriptive, right? So when you're talking about the word here, I would be having numerical measures. Now, how would I describe, or how would I give information about the data when there's no numerical source, right? I cannot say that there is 20 point, or I cannot say that there is good change, or I cannot say that the mean is very different. Now, if someone asks you how different it is, it has to be quantifiable. So you would always have a precise value, like it could be any random number, but the value is precise. All right, and it generally tells you about the data set. All right, it gives you deep insights about your data set, like what's the mean, the range. Now we all know what is the range. Range is minimum to maximum. It gives you the frequency distribution. It gives you the quartiles, all the four quartiles. It talks about the mean standard deviation or mean absolute deviation, different types of deviations. It gives you variance and standard deviation. Well, both of them are not very different from each other, variance and standard deviation. So we'll keep to that. So yes, so these are the different kinds of measures, or these are the different kinds of information or insights that you would be able to have about your data set when you talk about descriptive statistics. But going further, when you talk about inferential statistics here, you would be having tests, or you would be having hypothesis on a higher side. It's more about having hypothesis, or it's more about proving something, or it's more about showing whether it's right or wrong. This is where we focus more on inferential statistics, and in this regards, we have one sample test which is used, again, a hypothesis test. We have confidence intervals, we have chi-square test statistic, we have t-test or ANOVA test, we have Pearson correlation, bivariate regression, F ratio, z-score, t-score. So as you can see, all of these are a part of machine learning, or I can say, different machine learning matrix. I see we have matrix related to regression, and we have matrix related to classification as well. And these matrix which we're talking about here, these are called inferential statistics. Right now, when we talk about inferential statistics and descriptive statistics, the difference is not huge. The difference is pretty low. And now, in the upcoming slide, let us understand what it is. So, talking about the difference between them, as I said, it's not huge. It's very minor. And in descriptive statistics, you would be having measurements. as I said, like mean, standard deviation, range, etc. But when you talk about inferential, the focus here is different. Okay, they start with a sample and then generalize into a population. Now, this word is very important. Well, I might have rubbed it off completely with a pen. I might have I'm sure it's not visible, so yes, I have deleted it. I'll keep it a bit simple to read. The most important part is they generalize into a population, and this information about population is not stated as a number. It's rather given to us as an understanding, and it depends on us to understand the data from here. It's an inference given about the description. That's how inferential statistics works, right? So if you could go refer the dictionary about the word inference, inference is giving a meaning or giving an insight. So inferential statistics, it's inferential statistics is trying to give you an inference about the description provided. It's as simple as that, right? So let's not complicate it, and we'll keep it to that. So as you can see, instead scientists express these parameters as a range of potential numbers along with degrees of confidence. Now, talking about the most important topic, that is importance of statistics. Do we really need them? Well, yes, they're very, very important for many reasons. But then some crisp, statable reasons are they provide you a very clear picture on the work that you're about to do on a daily basis. Like it could be graphs, or it could be something to do with numbers or anything. They give you a great deal on how to work. The statistical method helps us to research on different streams such as medicine, economics, business, social science, and so on. Well, there's a lot of things we could do, archaeological surveys, when something is excavated, all these datings, all the number calculation that happens is thanks to statistics. Then it provides us different types of organized data with the help of graphs and diagrams and charts. That's exactly what I was trying to tell you here. And then they come handy while you're doing critical analysis. Now, critical analysis could be anything, and it could be related to any stream. It could be related to medicine or economics or business or social science or anything. So there is no one particular field or stream that I would like to narrow down to when I talk about critical analysis. But yes, there are a lot of insights that you would be having from or through statistics. So hence, it would be very wrong for any of us to say that statistics is not important, A, and B, you would be requiring heavy mathematical insights to understand statistics. Well, both of them are wrong. Even if you are a basic graduate, and even if you have basic flair on numbers, and I think a basic practice and some insights about what is what, which we would be focusing very shortly in the videos to come. We would be looking, or we would be covering at a complete video, or probably a set of videos focusing on the important terminologies related to statistics. But then statistics are important, and as I said, they're nothing something to be very scared of. Even if you're good, and even if you have an inclination towards numbers, I think you can, or you should be able to pull it off very easily, because all of these are something that we have done right when we were at our schooling. But this is looking at it, or probably at a digital front, and definitely at a bit of an elevated level. So yes, and without forgetting, if in case you feel that this video has helped you, please hit the like button. It is right there. Well, I would like to write it. I would like to ensure that it's visible to all of you. Please hit the like button. That would encourage me to do further. You also have the share button, which I would like you to hit upon. Share this with your friends if you feel that this video has been of any use to you. And also do hit the subscribe button, because there's a lot yet to be exchanged, and a lot of knowledge yet to be transferred, or yet to be shared between us. Have a great day. Thanks a lot for watching. This is me, Varun, your mentor, your trainer, or your well-wisher, or whatever you want to call. Signing off. Have a great day and all the best.